Okay, great. So hello, everyone. I will be giving the final review for 352. And first things first is the ground rules. So if you have a question, please raise your hand, and if you have a question, please don't be afraid to ask it, because the whole point of this is that I explain things in a hopefully slightly less confusing way to you. And so the big benefit is that you would ask questions and we can go back and forth. And I guarantee you, if you have a question, someone else somewhere probably also had the same question. So it's useful for everyone. If I feels like I made a mistake, please also raise your hand and or unmute and say something, especially because it's possible I made a typo somewhere or something like that. So yeah. And finally, yes, if you want the notes, if you're watching this on the ESA YouTube and do not have access to it, you can email me. Whoops, that is not the at this. To get the notes, and they're mostly examples, so hopefully they're useful, and hopefully all of you have the notes as well, but it's also okay if you don't have it. But yeah, okay, so I will begin, and I feel like I would rather begin with one period onwards, just because I feel like the final exam is usually quite second semester heavy, so I'm gonna start there. Yeah. So how this is going to work is that I have made us some examples, and I'm going to explain how I would think through those examples. And if you have any confusion at all, or yeah, any worry or query, stop me at any time. So yeah, the first example is about an individual with this following preferences. So yeah, this preference function, and over here they receive labor income which is equal to their real wage. So this real wage is W, multiplied by the fraction of the day they work, N. So in this case, it's different than you have a total number of hours H. You normalize it all to be a fraction of the day. So they also receive a lump sum transfer T from the government, which is financed from abroad. And over here, the key thing is that since it's financed from abroad, the taxation and government expenditure remains the same. And so how you would solve for a one period model is that you would realize that the consumer would want to work optimally. But what is the consumer's optimal amount of work? So they have a utility function, and then they have a budget constraint. And then based on the budget constraint, it's the same as a micro, they optimize the utility function based on that. So in this case, the budget constraint is Wn plus T equals to C. So Wn plus T is basically how much the consumer earns, right? So if the consumer works N proportion of the day and you multiply that by the wage, then that's how much they earn by working. And then you add the T because it's a lump sum transfer. So the government is giving them money, basically. And so what this equation is basically saying is that everything that I earn is equal to what I can spend. I can't spend more than I earn, and I can't earn more than I spend. So that's my budget constraint. And then from here, you want to derive the consumer's optimal work choices, right? And so how you would want to do this is that based on this equation here, so I want to write it in terms of N, because this equation is also in terms of N. I want to write it in terms of N and C. So if I write that equation in terms of N and C, what I get is UCN equals to theta ln, what's L, right? So L is the fraction of the day that you you are not working. So that is 1 minus the fraction of the day that you're working. So plus 1 minus theta ln C. So this is another way for us to write our utility function. But then if I already know that the budget constraint is this, so I could do the Lagrangian and make it kind of messy, or I could just say that since I know C is exactly equals to Wn plus T, I just replace this with Wn plus T, like I did here. And then from here, it is just taking the derivative. I'm hoping that you can do that. And yeah, so you take the derivative, you solve, and you solve, and you solve, and you solve. And then you finally get the optimal amount of labor effort. And then over here, the key thing to notice is that, see, theta is the parameter that shows the relative importance of consumption. So of course, as the importance of consumption decreases, like as the importance of consumption increases, you would work. Okay, like theta is like how much you basically like how much you would, the relative importance of consumption to leisure. So over here, as theta increases, your work effort decreases, which means that theta is like how much you prefer leisure activity over here. So increases with theta as compared to consumption. Not only that, but you have transfers, right? So this implies that as the transfers the government gives you increases, you are less likely to work, which kind of makes sense, given that, you know, if you have other means of acquiring income, you would want to work less because of the income effect. Yes. And so this is the usual like start of the derivation for the on the consumer side. And then sometimes there's the derivation for the producer side, but the producer side is really the same as the derivation for the solo model, where you basically get at the end of the day, what you get is that MPN equals to W, and then you solve for everything around that. So that's the producer side, which is why I didn't really put anything about it. But yeah, so assume that you have an economy that's at equilibrium and the standard one period model of consumption. So suddenly there's an increase in total factor productivity. So Z goes up because, like, let's say like computers were suddenly invented. So each amount of like all of your productive capacities increase. So discuss the effects of this increase in total factor productivity. So the way that you do one period is like everything goes back to labor, right? So with your shock, so your first shock is the like change in total factor productivity. So using this shock, and usually what I like to do before I try to write out a whole answer is that I will do something like, I'll be like, okay, so increase in Z means that there's like increase in ND, and then decrease in NS. And then like, I'll basically like think of all the scenarios and then write it out in symbol form first before I try to write out all the words, because like it helps you analyze the final effect. And sometimes it's also useful for you to start trying to draw the graph. And then once you have the graph more or less settled and you kind of figured out all of the effects, then you start writing, and because then you can form kind of a coherent narrative of what's going on, instead of like, as you write, you're kind of figuring it out. Whereas if you just like write the symbols like increase Z, increase D, ND, decrease NS, and then like and then you figure that side out, then I think it goes much smoother. At least for me, it goes much smoother. And it really helps clarify your thinking. So, and this is a smaller model, so it's not that hard. But as it goes further, it's really, really useful for me, like, okay, if there's an increase in K, then there's two different ways that it can split up into. Yeah, so it's, yeah. But yeah, so getting back to this, with an increase in total factor productivity, so there's an increase in marginal product of labor. And that's the reason for the increase in marginal product of labor is because as marginal product of labor increases with the total factor productivity and the quantity of capital, because then it's like each unit of labor is more productive. So since the firm's solution, as I mentioned before, is the marginal product of labor equals to wage, and wage doesn't increase, this leads to a shift in the right of labor demand. So basically the firms want to find it optimal to hire more people just because each person is more productive in their eyes. So there's an increase in labor demand. And on top of that, because of the income effect, where the representative consumer suddenly is getting more money, getting more money because of the increase in productivity and output, the labor supply decreases because they find it less useful to be working. So at the initial wage, there's going to be, so after you've analyzed like the initial changes in the graph, and then you can draw them. So at the initial wage, there's going to be excess demand. So this excess demand is everything from here to here, right? And how you figure that out is that at this initial wage, you have your new labor supply and new labor demand. So it's these two lines. And so at this wage, your new quantity supplied is this much, and your new quantity demanded is this much. And clearly there's an excess demand, right? And so there's going to be an increase in wages to move it along these two curves back until they reach the new equilibrium. So the standard, oh yes, Sarish.
Don't we say that the wage, like labor supply is positive in wage, so as the wage increases, doesn't labor supply increase? Because I think he says that like we assume the substitution effect dominates the income effect.
Yeah, so the reason why as wages increase, it is true that labor supply increases, but it's more quantity of labor supply increases. So at the initial shock, you have your two new labor supply and labor demand, right? And the reason why this is a complete shift of the curve is because it's not any of these axes. Z isn't in any of these axes. So it's equivalent to like at every single wage level, you have a decrease in demand. You have a decrease in supply at every single possible wage level.
Okay, and so I just thought that I think in his notes, he says that the only thing that causes like shifts in the labor supply curve is taxes and like pi, which is like the profits that you get, like the.
So this income effect is basically due to their lifetime wealth. The change in their lifetime wealth there is a change in their lifetime wealth because there is more output that is being created in the economy.
Okay, got it.
So this is a different income effect, right? This is not the income effect because of changes in wages. This is income effect because I am suddenly a richer person, and I don't, as a richer person, if I were richer today, I would not work as much as I do today. So that's what this income effect is.
Okay, thank you.
And for this wage effect, it's basically saying that, okay, so now at this original wage, supply is here and demand is here, and that's never good because you always want them to cross, right? So the standard explanation for how you resolve this thing is that as the wage increase, like this induces an increase in wages, and then as the wages increase, then the quantity of labor supply increases because more individuals want to work now because they're getting paid more to work. And then at the same time, as wages increase, producers don't want to employ so many individuals anymore because they're expensive and they don't want to pay them. So they just basically move along this line until they reach their new equilibrium and everything's good. So not only that, but at this new equilibrium, the wage is higher. And not only that, but also output is higher. And the reason why output is also higher is because an increase in total factor productivity also increases the amount you can produce with the same amount of labor and same amount of capital. Just because like the equation we're given is that this is basically equals to like the most common one we're given is that this equals to zk alpha n 1 minus alpha. So at different, as Z increases, the output is also going to increase, which means that, yeah, so this is basically the effect of the increase in total factor productivity. You can't really say anything about employment because it really depends on to what extent these two lines change. So I could draw an example where, let's say, supply decreases a lot more than demand increases. So this is the original equilibrium, and this is the new equilibrium. And you can see that like the employment would decrease. And that makes sense because if you have way less people who are able to work, then the increase in demand for workers, then you will not be able to induce more people to work, and therefore you would have less people working. But let's say the increase in demand of workers, so this is ND0, this is ND1, is much greater than the decrease in supply. So this is N0S. And then this is N1S. So 0, 0, the first equilibrium is here, 1, 1, the second equilibrium is here. And so you can see that it's kind of indeterminate. And so without having extra information, you can't really tell what happens to employment. But if you had the extra information that one shift is much bigger than the other, then you would know what happens to employment, basically. And also, because we know that output equals to consumption plus government expenditure, and in this situation, there's no investment because it's one period. So this is all that output is made out of. If we know that output increased and government expenditure remained the same, then we know that consumption was the thing that made output increase. So specifically, the consumer is consuming more now, which is good. So yeah, that's the analysis for one period. Does anyone have any questions? Or any other questions about one period? Okay, so I guess we can move on to the 2-period model. Yeah, but don't hesitate. If you have any questions at any time, even if it's about previous things, I would be down to take them. And if you feel uncomfortable asking questions, we can also wait till the end and then we can go over it. So yeah, so the 2-period model is basically, the 1-period model is complex because you have both the producer and the consumer, and then you have to solve the producer problem and the consumer problem in order to find an equilibrium. The 2-period model is complex because now you create 2 time periods where you care both about current things and future things. And you have a mechanism to move between the current and the future, which is basically interest rates and savings. But in this situation, we would also abstract from figuring out exactly what the producers are doing and the exact solution of the producer's problem, just because we don't really want to bog down the model so quickly. So we're kind of like building it up, right? So before we know, like in the previous situation, we know how a consumer and producer would act in one period. Now, suppose it's just a consumer, and suppose the consumer is given some endowment. How would they act across 2 periods? So that's the interesting question that we're dealing with. And most of the time, and I haven't seen a single counterexample in any of his like things, is that he always uses this individual preference relation. And it's probably because it does have some nice properties. And it's really important to use this relation just because it like algebraically, I think it gives you the consumption smoothing that you want. So, but yeah, we'll go over, you'll see consumption smoothing in like a minute. So yeah, so the terminology is C is current consumption. C prime is future consumption. So any variable which is the future, it has prime on it. So endowment. So I mentioned before, there's no solution. They don't solve any like consumer producer problem. They just get some money that they spend. So they get some money today. Why? and they get some tomorrow, y prime. They are taxed at a rate of t today and t prime tomorrow. There's a financial market in which they can borrow and lend at a rate r. So that's basically how you send money into the future, or borrow money from your future self and take it now. And the government uses the taxed income t and t prime to fund government spending today and tomorrow. So yeah, the first thing is to derive the direction and magnitude of a change in current consumption with respect to current income, and explain the cause for this response. So the consumer's lifetime budget constraint is, well, the consumer's budget constraint in the first period is y minus t equals to c. So how much you earn versus how much you're taxed equals to how much you can consume. Right. And sorry, and plus s. So you can either consume or save. So you have options, right? And then in the second period, whatever that you saved becomes part of your income. So it's y prime minus t. One plus r s equals to c prime. And this lifetime budget constraint is basically saying, okay, so you have s in both of these situations. So how about we just solve for s and then mash both equations together, and then you would have the lifetime budget constraint. So like it because over here, how much you borrowed or lent in the first period must come back to you in the future. So using that relation, you get this lifetime budget constraint. And yes, go on.
Sorry, I might be a bit mixed up, but so in the 2-period model, they don't decide whether to work or not. The work leisure choice is not okay.
No, yeah, exactly. That's why the 2-period model is a different type of model than the 1-period model. So the 1-period model is all about consumption leisure choices, and then how that interacts with like producers and how that decides the labor demand. But the 2-period model is specifically looking at intertemporal choice. So all I care about is how the consumer would make a decision between getting money today and getting money tomorrow. And you can combine that in the future, and we will, to say that like, this is how much money you're getting today and this is how much money you're getting tomorrow. So the amount of money you're getting today is based on your work and leisure choices. That's how you would be able to decide that. And then from there, you can decide how much you would want to leave for tomorrow and how much you would want to spend today. Does that make sense?
Yeah, sounds good. Thank you. Okay,
awesome. So this is, again, the same as micro, right? Which is why these chapters are more intuitive, in my opinion. But you have a utility function. You have a budget constraint. So whenever that happens to you, what you do is you just maximize the utility function with respect to the budget constraint. So since you have this utility function, then what you would end up doing is basically, yeah, taking the derivative. So you get UC equals to 1 over C, UC prime equals to 1 over C prime. Then the marginal rate of substitution you would get is UC over UC prime, which equals to C prime over C. And you know that this marginal rate of substitution must equal to the interest rate at equilibrium. And the reason why that it must equal to this interest rate is because suppose that this marginal rate of substitution between consumption today and consumption tomorrow is greater than the interest rate. Then you would be better off to borrow, like, borrow a little bit more and and consume a little bit more today. So then that wouldn't be the optimal consumption choice. And in the converse, if the MRS is too small, then you would be incentivized to consume more today, because it would still be rational for you to at the interest rate level of 1 plus R, you would still want to you would consume more today, sorry, and save less for tomorrow, because it's not worth it and you don't get as much gains from saving. Does that make sense? Okay. So if you solve for this, you get C prime equals to C prime equals to C times 1 plus R. And then from this equation, you have actually that C prime equals to all of this. And then at this point, you're basically just solving for C. And you solve, and this is the final thing. This is the final value of C that you get. Would anyone like me to go through it? But it really is just algebra. And the intuition is really just that, like, this is your optimality condition on how much the consumer will decide to consume, like split current and future consumption with, is based on how the interest rate is. And then from there, you just solve your lifetime budget constraint in order to get your solution. And so with this solution, we can do something pretty cool, which is we can take the partial derivative of the consumption with respect to income. So now we get the response of, let's say there is a 1 unit increase in income today. So how will consumption change? And now we know that the current consumption change. And now we know that current consumption will change by exactly half units. And this makes a lot of sense because as income increases, basically what the consumer is doing is saying, like, okay, I have $100 extra today. I have to split them between period 1 and period 2. I'm going to spend 50 on period 1 and 50 on period 2. And this is because of consumption smoothing. And so the whole principle of consumption smoothing is that you as a consumer don't want to be like example, if like you hit the lottery today, would you want to spend all of your lottery winnings all in today and be dirt for tomorrow? You wouldn't really want to do that. But at the same time, you would still want to spend something today instead of saving it all for tomorrow and then like splurging it all then. So it seems pretty intuitive that consumers want to spread out their earnings over a longer period of time. And that's what they usually aim to do, which is why there will be consumption smoothing, because of their preference for variety. And so, yeah. And we know from before that in the first period, y minus t equals to c plus s. So your net income equals to your consumptions plus savings. So if your change in consumption, whenever you're like, let's say for each increase in income, your current consumption increases by half, then your savings must also by definition increase by half, because that's the only places where it goes. So this implies that like the timing of income is the main cause of why people would save. You know, it's like income today versus income tomorrow is what makes the difference between how much people are saving, not necessarily the total amount of income itself. And yeah, so back to like the function that I mentioned just now, I feel like if this were to come on an exam, I do think that this is one of the only utility functions that you can use, just because the consumption smoothing is such an important part of a two-period model. So if you ever see any different function for the two-period model and it doesn't have this nice properties, like immediately you can say that it is of consequence that they do not experience consumption smoothing, which is a very big violation of like the common assumptions that we have. So that's just something to keep an eye out for. And yeah, so there's also Ricardian equivalence, which is basically saying that the government spends money and that's fine, but it does not matter when the government is pulling the money from you. It just matters how much money the government is pulling from you. And this kind of aligns very nicely with the narrative before, that savings is not about how much like your savings and total consumption isn't about how, like when you're given money, it's about how you have your lifetime wealth, and then you optimize with respect to that, and your savings is a way to move money back and forth in between. But then at the end of the day, when you're thinking about the decision that you're making, all you care about is like, I have this amount of wealth in total, and I'm optimizing with respect to that. And so how you would prove Ricardian equivalence is that based on the household budget constraint, you have that consumption equals to income minus taxes. And so because of the government's budget constraint, you must have that the total amount that you tax is the total amount that you spend, because you can't spend more than you tax, but you also wouldn't tax more than you spend. And so in this situation, you get that the total amount, like your lifetime consumption, equals to your lifetime wealth minus the government's lifetime expenditure. It doesn't matter when the government spends the money. If the government spent less money today because they were going to spend more money tomorrow, the consumer would be like, oh, okay, they're going to if the government taxed you less today because they were going to tax you more tomorrow, the consumer is going to think that like, okay, they're taxing me less today, but they are spending money, and I know that they're spending money, and there's only 2 periods, and they can't end tomorrow with a deficit. That means tomorrow they're going to tax me more. So then they'll be transferring their money over to the second period so that they're not too affected by the second period tax. So at the end of the day, it doesn't really matter like if you're taxing today or tomorrow. The consumer is just gonna like use the savings to move back and forth, like move money back and forward, so that it doesn't really matter. Does that make sense? Okay. And is there any questions about 2 period, I guess? Like, I feel like these are all hopefully different examples than ones you've seen before. And so you being able to like look through them and understand the explanation is pretty key, just because, yeah. Okay, then we have, oh, Nikos, yes.
Sorry, it's just for the Ricardian equivalence again. I'm not sure I understand how this last line proves it.
Yeah.
Like,
so
yeah.
What you notice is that you suddenly have the consumer's lifetime consumption is based, you can base it only on the exogenous like variables of your lifetime income and the lifetime government expenditure. And so these are all like variables that are not dependent on the tax today or tax tomorrow.
Okay, yeah, I see. Okay, thank you.
So this is this is exogenously determined. And so once you have this consumption in terms of these 2 exogenous variables, then you're like, okay, I'm good, because that implies that the consumption was already set when you first started. Yes, Isor.
Yes, so when it says that the timing of taxation does not impact consumption, it does not impact the level, right? But the timing changes.
Yeah, I think it doesn't impact the total consumption, like the lifetime.
Okay, thank you.
But it is true that different timing of taxes, would it affect, let me think and look through the notes. Would it affect Ali? Yes.
So just back up to the page before that. Did you say the marginal rate of substitution between consumption in the future and now is indifferent?
Marginal rate of substitution between consumption in the future and now is indifferent.
Is that true? Because you said it's 1 plus R.
Yeah.
Right. But
I mean, it has to be 1.
Half of the increase goes towards current consumption, and then half goes to future.
Yes, half of the increase. Well, half of the increase when it comes to an increase in income goes to consumption and like current consumption, and half of it goes to future consumption.
But so they would rather spend more now?
I think they would rather spend exactly the same, so if I were giving you money today, I would like what this is saying is that I'm going to split my money in half. I'm going to spend half of it today and half of it tomorrow.
So over your lifetime wealth, 50% in the current period and 50% in the future?
If it's not your lifetime wealth, is that 50% is in the current, 50% is the future, is that if I gave you extra money right now, where is that extra money going to be split across? So they're going to give you the half of that money is going to be spent today and half of that money is going to be spent tomorrow.
Okay, thank you.
But then the optimal amount of consumption today and tomorrow is really more dependent on the interest rate. Just because this optimal consumption of so maybe something that if half of it went towards savings, that means tomorrow your increase in consumption is 1 plus R over 2. Just because you do get the extra interest rate from spending tomorrow. So your increase in consumption today was half. Your increase in consumption tomorrow is 1 plus R over 2. Your increase in consumption today is 1 over 2. And you get back the interest rate. Does that make sense?
Yeah.
So basically it's like saying okay, I give you half the money. What you're going to do is you're going to spend half now, but then you're going to save the other half. When you save the other half, it doesn't just you don't just get half tomorrow, you get 1 plus R half tomorrow. So it's still with that 1 plus R half over here. Then when you divide that by the half that you had yesterday, it also still equals to the interest rate. Does that make sense?
Yeah, that makes sense. Thank you.
Okay. Yes. Okay. No, I think it is for, I think it is for current consumption that they're not. Yeah, I think for any consumption choice, it doesn't matter if they're the C and C prime will be exactly the same. And so basically, okay, I will restart the explanation. The consumer solves for an optimal level of C and C prime based on the value of 1 plus R. Let's say the government tries to tax more today or tax more tomorrow. Then the consumer will be okay, I anticipate that and I borrow enough such that I can still consume C today and C prime tomorrow. Does that make sense?
Yeah.
I think someone else also had that question. Is that a clear explanation?
I'm just not sure why the level then wouldn't change.
The level wouldn't change?
Yeah, because you said C and C prime stays the same.
Yes. So C and C prime stays the same because the consumer can basically use savings to move money back and forth between the two periods.
Okay.
So if the government decided to tax more today, then the consumer would use borrowing to pull money from tomorrow to make sure today they still manage to hit their optimal C.
Okay.
Because C is optimal to them and they want to be able to maximize to C today and C prime tomorrow. That's the amount that they want to consume. And so that amount since that amount is optimal, if they consume less today or consume more today, that's bad for them, right? And they are able to borrow and save as much as they like, as long as tomorrow they pay it off. So essentially what's happening is that once they've solved for the optimal conditions, then as soon as the government announces the amount of tax they're doing today, then they're okay, I know how much I need to either borrow from tomorrow or lend to tomorrow in order for me to get C and C prime.
Okay, so only savings change, not the level of consumption.
Yes.
Okay, got it.
Any other questions? These are good questions. No? Okay.
If the government
Yeah.
increases their spending total throughout the 2 periods, we will see a change.
Yeah.
So, in consumption. Okay, great, thank you.
This is more like it doesn't matter when they ask you for money. Like, you know how much money they're going to be asking you for. And so if they ask you for less money today, because they're going to ask you for more money tomorrow, the consumer is like, I know what you're up to. And then still would like save today so that they can reach they would just consume until C today and then save the rest so that they can pay the taxes tomorrow. Okay. Any other questions? Yes. Ian.
Sorry, I just had a question about like the marginal rate of substitution between like consumption and consumption in the future. Like,
Yeah.
I know that it's 1 plus R if I remember correctly, but like I don't understand why specifically that has to be the marginal rate of substitution between the two.
Yeah. So 1 plus R is basically how you can transmit money into the future, right? And so you want like the amount of consumption tomorrow to be like the proportion of consumption tomorrow and consumption today to be 1 plus R. Because if it was less than 1 plus R and you were consuming, okay, I'll write it out clearly, actually. Okay. So suppose that the MRS of C and C prime was less than 1 plus R. And so this implies that C prime is less than 1 plus R of C. And so what you could basically do is you could decrease the consumption, today, or is it, let me think. Okay, which sign needs to go down if you decrease consumption today? Okay, I shouldn't do this line. But regardless, that means that the price of consumption today is it's either that you can increase consumption today or increase consumption tomorrow. Let me think. So
Sorry, it's more like what the difference is between like the marginal rate of substitution between the 2 periods and saying that we're going to save half of our money in the current period.
oh, it's the same question as before, I guess. So you're going to save half your money in the current period, and then you're going to save the other half. And then in the second period, it's going to become 1 over R, 1 plus R over half. And then when you solve for that condition, then it gets you 1 plus R back.
Oh, okay. Thank you.
But yeah, the sign here is like either this means that you should be consuming more today or consuming more tomorrow. But like one or the other. But it's basically like 1 plus R is the price of moving money back and forth, right? And so if you can move money to tomorrow for a price of 1 plus R, and you would gain more benefit from that, then you would move the money. If you were moving enough money such that your marginal benefit from moving that money was less than the price of doing it, then you would move less money and then you would consume more today. That's the answer. So like basically 1 plus R is the price of moving money from today to tomorrow, right? So if your marginal benefit from doing this is less than the price of moving the money, then you would just decide to keep more money in today. But then if your marginal benefit of moving money to tomorrow is greater than the price of moving money tomorrow, then you would move more money to tomorrow. So in the optimality condition, you must have like the marginal benefit for like the money movement between today, like today's consumption and tomorrow, has to be exactly equal to the price of moving money from today to tomorrow.
Okay, that makes sense.
Okay. Any other questions? Also, I just realized this is the marginal benefit and this is the price. Sorry. And this is quite literally the price because it's the amount of current consumption of future consumption you give up by increasing current consumption. So any other questions? I could also like re-explain if anyone found it unclear.
Quick question. So MRS is equal to 1 plus R, right?
Yeah.
And so what was the bigger or smaller sign?
So
I must have missed that.
So this is the benefit from saving your money today.
Mm-hmm.
And this is the cost of like saving your money today.
Mm-hmm.
So you must have them to be equal. Otherwise, you would want to move money back and forth.
Exactly. Yeah.
Yeah.
So that was just to explain the idea.
Yeah, exactly.
Okay, that makes sense. Thank you.
Any other questions? And like don't worry about asking questions because also like I have like one example for each section, so it's not gonna take like super long. So the benefit is for you to like clarify at any point if you're confused. Okay, I guess the real business cycle. The nice thing about Francisco is that he's gonna give you these things. So you don't have to remember this, which is wonderful because that would be awful. But yeah, so assume that the government again receives a transfer from the rest of the world. Yes, Ali.
Wait, I'm sorry. I was just double checking. He said that you did need to memorize these. Did he like tell you that you didn't?
He said that you have to memorize these?
Yeah, when I asked him.
Because in every single previous practice, midterm, final, everything, I've always seen these there already. But Alexandra, do you know, or like, does anyone know about this?
Yeah, so like he has mentioned like that if he, it was very vague. We asked him like before the midterm, he was like, oh, like whatever I feel like you guys need to answer the question, I'll like provide it for you, which is unclear, but that's all as much as I can provide, if that makes anything clearer.
Give you these on the midterm?
I don't think he gave it for the midterm anyways.
He didn't?
Because the question didn't need it. He said if the question, like if he asked you, like if he has a question, he'll provide you like the necessary formulas and stuff that he thinks you'll need to answer the question.
Okay. So he will most probably give you this. And I will say that like for the stuff in the future, like these things, like this and stuff like that, he kind of has to give you because there are many different formulations of it. Like there are many different ways to parameterize and like give you the equation. Like there are many different versions of the equation. So he would probably have to give you the exact ones for those. But for this one, maybe record again. I will heal the recordings later. Have no fear. We were talking about this. And I was saying it would be probably good for you to memorize them, but I also would not blame you if you did not. Because you can also kind of derive them, kind of. Like, suppose you were a worker. If wages increased, you would work more. You know, that kind of thing. I feel like that's something you could figure out very easily. Or like if taxes increased, you would work more, both today and tomorrow. Suppose you were a producer. If wages increased, you would want less workers. That kind of thing. So I feel like you know, regardless, it's gonna be fine. But also, yeah, if you don't want to leave things up to chance, which is probably a good idea, you could also memorize it. It'll probably take you like 15 minutes and then you'll be fine. Let me just check that I'm recording. Yes, okay, I'm recording. Great. Okay. Okay. We keep trucking. Any questions before I start the real business cycle? Okay, no. All good then. Okay. So the government receives a transfer from the rest of the world and uses it to subsidize consumer work effort in the current period. So since this subsidy is financed from the transfer from abroad, so there's no change in government expenditure and taxes for either period of the model. And that's also like sometimes how people, like it's difficult to come up with interesting ways in which you could change one specific parameter. So sometimes they come up with like stuff like this, where you're like, okay, transfer from the rest of the world. And then you have to look very carefully on the exact conditions, because you can't just see like subsidy, okay, taxes increased, you know, like you have to, how he usually comes up with these questions, it's like he designs a question to like tweak one specific part. So you have to read very carefully the words in the question, not just like zone in on like one or two parts of it. Yeah. So for each additional hour worked by the consumer in the current period, the government rebates to the customer S, which is the subsidy in the same period. So we restrict our analysis to the current period like we always do, because we are mostly interested in how everything reacts to the current period in the real business cycle. And so, yeah, derive the new optimal consumption and leisure choice of the consumer, explain the effects of the subsidy on labor supply and labor demand, and modify accordingly the labor supply and labor demand curves. So the new lifetime budget constraint, well, the old lifetime budget constraint, maybe I should write that first, was your wages multiplied by how much you worked plus your profit minus the taxes. That's today. And then tomorrow's wages times how much you work tomorrow plus tomorrow's profit minus tomorrow's taxes divided by, you know, the present value equals to the total consumption. So here's our lifetime budget constraint, right? But then over here, I said that specifically today, you know, when you are waged more, well, you basically, when you work more, you get paid more. So over here, this becomes W plus S. And so if the representative consumer maximizes their preferences, so they have some utility function and they have the budget constraint, which is basically the name of the game for most of the analytical problems that you'll be solving for this exam. So find your utility function. If like they say something analytical, find your utility function, find your budget constraint, make sure that everything all checks out, and then Lagrangian, and you're good. So this is our new utility function. It looks complicated, but we only care about its effects on, again, labor supply, labor demand. So consumption, consumption today, consumption tomorrow, like the effects of consumption today, consumption tomorrow, leisure today and leisure tomorrow, because that's what the consumer actually chooses between and can influence. Everything else is kind of just given to them. So the profit you have today, the taxes you're facing, that kind of stuff. So like that's kind of just given, but the consumer can choose their consumption and leisure, and then they choose that to optimize. So if you take the derivative with respect to consumption, you get that this, like these are basically the first order conditions. So yeah, this, yeah, so I feel like you could probably derive these. These are the same as the ones that are actually in the notes. The only thing that's different, and I noticed that there's a typo here because of a clown, but here's the thing that's different. So instead of W, you would have W plus S, because if you derive with respect to L, then you get, wow, whoops, sorry, my palm just made it fly. Yeah, so you get UL plus lambda minus 1 W plus S equals to 0, which means that UL equals to lambda W plus S. So this is the only different condition. So our new optimal consumption and leisure choices are that the amount that you want to work with respect to, like, to enjoy leisure with respect to consumption, which requires more work, is now W plus H instead of W. And then all of the other conditions are the same. And how you get these is basically from before you take UL divided by UC, UL prime divided by UC prime, and UC divided by UC prime. But this is like the same as always, basically. Yeah. So with a subsidy on work effort, the marginal benefit of current leisure relative to future leisure increases. So basically, if I am paid more to work today than I was before, then I would decide to work a little bit more today, right? And then I would move more towards working more today and maybe working less tomorrow. So I would reduce my leisure today, and that would increase the labor supply. But at the same time, and if you were thinking about this using only the equations from above, then you'd be like, okay, so if labor supply increases in the wage, then labor demand should decrease in the wage as well. But this wouldn't make sense in this situation, because the firm isn't the one that's paying the subsidy, the government is. So for the firm, their problem remains exactly the same. So I pay them wages until I pay them the wage W. And then I optimize until MPN equals to W. I don't need to pay the extra subsidy. So there's no decrease in labor demand because I'm still paying the same amount. And so it's very easy to, like, when you're thinking about things very fast, to be like, okay, so W plus S is the new wage, and then you just substitute everything in. So if wage increased, then labor supply increases, labor demand decreases. But over here, it really matters who's making the decisions. So since the firms only have to pay the original wage W, the firm's problems, yeah, unchanged. So the current labor demand curve remains unchanged. So there's, yeah, no addition. Yes, Isar.
Yes, I'm just not sure why it's W plus H and not W plus S for the.
Because I made a typo.
Oh, okay, so it is S.
Yes.
Okay, perfect. Thank you.
You can tell which chapters I did while I was sleepier. Okay, sorry. Yes. Yeah. Any other questions? Thank you, by the way. See, that's what I mean by, if you feel like something is wrong, just say it. It's probably that I made a mistake. Okay, so the next part of the question is, like, you should trace the macroeconomic response of the economy after you have the subsidy. And this is using the graphs for labor market and the goods market. So one of the first time we're using the new exciting graphs that we'll be seeing a lot, which is exciting. Yeah, so then discuss the adjustment on the economy, specifically the effects on output, employment, wages, and interest rate, which are the main determinants that we usually care about. And sorry, oh, yes, okay, there we go. Yeah, okay. And so when there is an introduction of the subsidy, as we mentioned before, there's a decrease in leisure. And so there's an increase in labor supply. So this labor supply curve moves outwards. And so again, as with our initial analysis, at our initial wage rate over here, there's excess supply, this one, because demand is here where it used to be, but then supply is all the way here now. And so what happens is that with this excess supply of labor, then the wages start to fall. And so they start falling until W1, which is where the firm finds it optimal to hire extra workers until there are N1 workers. So from there, because there was an increase in employment, you see over here, the number of workers went from N0 to N1, then there's also an increase in output supply. So this supply curve increases. And I mean, this is what you get from basically over here. And so yeah, so since there's additional employment, then you're basically there's an increase in output supply. And then what happens is that production increases until Y1 at the initial interest rate. So this shift creates excess supply once again, but this time in the goods market instead of the labor market. And so the interest rate starts to fall down towards R1 again. And so as the interest rate decreases, there are two forces that help close the gap. First is that working today, and sorry, yeah, no, this is that's too early of an explanation. As the interest rate decreases, then working today and saving becomes less attractive because you can't send as much money into the future. So people decide to work a little less. And then once again, this creates excess demand in the labor market that pushes the wages up to its new wage rate and also decreases employment. So there's a decrease in employment because of the decrease in interest rates. And not only that, but because of a decrease in interest rates, you also have an increase in consumption and investment. So basically, you kind of meet in the middle over here. Does that make sense? So like the two forces are that there's a decrease in employment because of a change in interest rates, which is a movement along this curve. And then there's a decrease in investment and consumption because of a decrease in interest rates, which is a movement along this curve. And then they finally meet in the middle and then they're back in equilibrium. But this is basically the structure of any of the real business cycle questions, right? So first thing is either there's an initial shock. Usually it's either to labor supply or labor demand. Sometimes it can be to output supply or output demand if it's directly like investment specifically is shocked. And so if there's so after that initial shock, there's either excess supply or excess demand in the labor market. And so how they close that excess supply or excess demand is by changing the wages. And so after you change the wages and then you change the level of employment, since you have now changed the level of employment, then if you increase employment, you can produce more things. If you decrease the employment, you can't produce as many things anymore. And so there's a movement in the output supply curve. And then from there, there'll be either excess supply or excess demand in the goods market. And due to the excess supply or excess demand, there's going to be an increase or decrease in interest rates. And that happens instantaneously. And so when the interest rates change, then since interest rates is one of the determinants of deciding on whether or not you want to work today, then the labor supply curve must change. And as interest rates change, it also changes whether or not you would decide to consume and invest, because the optimal level of investment depends a lot on interest rates. If the marginal benefit, if interest rates increased, you would decrease your investment because there are some marginal investments that are not worth it to invest in anymore. So they don't give you as much returns as the new interest rate, even though they did give you more returns than the old interest rate. So you wouldn't pursue those investment opportunities anymore. So it would decrease your investment. And like the converse is true. If there's a decrease in interest rates, then if there's a decrease in interest rates, then there are some projects that previously would not give you as much returns as the old interest rate, but now they give you more returns than the new interest rate. So you would start to pursue those projects, and that would cause investment to increase. And then as investment increases, consumption increases because of the law. Does that make sense? But yeah, that's like the standard answer for every single kind of RBC question. And so usually what I do is, once again, when I'm starting the question, I'm like, okay, there's an increase in labor supply. So if there's an increase in labor supply, then I'll write decrease in wages, increase in employment. And then I would say, okay, increase in output supply. And increase in output supply would cause a decrease in investment rate. Decrease in investment rate would create an increase in labor supply. Then I would split it off into two sections, right? So this would increase investment, increase consumption. And this increase in labor supply would, it's a decrease in labor supply. Yeah. Decrease in labor supply, which would increase wages, and then decrease output, which would decrease the quantity of output supplied. And then afterwards, I would draw the graphs, and then afterwards, I would write the words. And that came way faster because I had just explained everything, but it's totally okay if you open the question and you sit down and you look at it, and then you slowly, over the course of 3 minutes, reason through all of this. Because it's very bad if you start writing an explanation and then you waste a lot of words writing it, and then you realize halfway that shit, it's actually the other way around, which happens a lot because sometimes it does get muddled, but then it becomes more second nature if you just write out all the symbols first and write out all the causes and all of the effects in short, simple terms. And then after that, you care about doing all of these, doing the connections between all of these, because okay, why does as wages fall, then firms find it optimal to hire additional workers. That's the explanation for why for why employment would increase. But then if you write that whole explanation and then you realize that it's actually the other way around, then you have to cancel that entire line and then rewrite it. And then it can get really messy and very confusing very fast. So what I would say is that when you approach the question, start at the beginning of the shock and then keep working step by step. And then at each step, make sure everything's good. And then once you have this entire thing, it's super easy to write out. Yes. And also, this is only one example. It's also useful for you to basically go into the notes that Francisco provided. And there'll be a title of what happens when there's an increase in total factor productivity. And don't look at what he wrote, just write it out all out yourself. And then look at what he wrote and then see if there's any differences or if any of the explanations are wrong. And then that's a very good way to practice, because otherwise it's very difficult to get practice for this. Because there's only because he never taught D2. So you only have our second midterm and our final. And that's the only content that you have to practice with. So you have to use the notes smartly. But yeah, and then the next part is what are the effects on consumption and investment, as I mentioned before, because there's a decrease in interest rates, then both consumption and investment increase. So that's usually good. So yeah. Any questions about the real business cycle? Okay. Short run model. Things are getting more complicated, but it's okay. You're going to get through it. So in this short run model, we have consumption and investment. And in this specific case, we have actually defined the exact parameters for consumption and investment. So before, what we had was basically IR. But then over here, the exact function that investment comprises of. So there's a base level of investment and it decreases as the interest rate increases. It's very simple standard investment curve. And this seems like I've looked through some of the stuff that he's given, at least for my final. And it seems like what he would usually do is he would, take a model that you know, and then like add a parameter or add a weird twist, or like ask you to analyze it in a different sense. So you have to get comfortable with these notions. D1 and D2. In these situations, it's just positive constants. So yeah, this was more or less like this was ripped from my final, except for I changed the question itself, but he did make it in terms of D1 and D2, and it was very gross because the traditional way is that it's like YL R plus I, but then he changed it up, so unfortunate. But yeah, any other questions before we get right into it? Okay, so the first question was use an ISLM diagram to determine the effects of an increase in base rate of investment, where the base rate of investment is B0, on output and interest rate. So explain your result. And this is just like a standard ISLM diagram analysis. So how this analysis goes is that, so there's a base rate of investment. If that increases, then there is an increase in planned expenditure, which shifts the IS curve to the right. So at the original interest rate over here, the original level of output, which is here, is less than the new planned expenditure, which is here, because this is the new IS curve, right? And so what happens when output falls short of planned expenditure is that firms are suddenly depleting their inventories, and they have like basically there's like unexpected demand, right? So they're depleting inventories, and so as in response to that, they start increasing production and employment, which results in an increase in output. So yeah, that's like one side of the analysis done. And then as income increases, so does like the demand of money for like transactional purposes. And so for the money market to remain in equilibrium, the interest rate needs to increase. So the interest rate increases till, the interest rate needs to increase. And so at this point, there are two forces that basically reduce the excess of planned expenditure over output. So first of all, output is increasing, which is good because like initially there was too little output and too much planned expenditure. So as output increases, because the firms are reacting to their unexpected like over demand, then output increases. And secondly, because the market money market needed to remain in equilibrium, then the interest rate starts to increase, and then there's this upwards movement on the LM curve, and that results in a decrease in investment. And since there's a decrease in investment, then planned expenditure also decreases. And so as before, the state was that output was too much below planned expenditure. So as output increases and planned expenditure decreases, they kind of meet in the middle. And then they finally get to this new equilibrium. Does that make sense? So basically, like the standard explanation for ISLM is that something changes either in the IS, like usually in the IS curve. So something changes. So you have your initial shock, and then either output is greater, initial output is greater than planned expenditure, or it's less than planned expenditure. And then there's the general like equilibrium adjustment. So as there's like a change in income, then there's a change in the demand for money, whether it's increase or decrease. and then there's a change in interest rate, and then that change in interest rate affects planned expenditure. And then the firms affect the change in output. Any questions about this? No? Okay. And so one way to do things is the graph, and the graph is very nice and very pretty. And most of the time you'll be very happy to use the graph, but sometimes they'll ask you to do things analytically. And maybe that's a little less fun, but yeah. So if I wanted you to analytically determine the effects of the same thing on output and interest rate, then you would, what the process of that which you would go by is basically, so first you write the IS curve, which is y equals to c plus I plus g. And this, as we were given before, equals to c0 plus c1 y minus t plus b0 minus b1 r plus g. And so since we want to see the effect of a change in b0 with respect to y and r, then we basically do differentiation on both sides. So what we get is dy equals to dc1, sorry, typo, c1 dy plus db0 minus b1 dr. So basically all the terms with y, r, and b not in them you want to keep. And then you can rewrite it like this. And then you do the same thing to the LM curve. So, and then you get this. And then from there, you can solve for dy in terms of d1, d2, and dr. And then when you plug that into the old equation, then you can basically derive dr over db. And then you can see that it's an increase, it's greater than 0, so it's increasing. And dy over db, which is also greater than 0, so you know it's increasing. And this corresponds to our result from earlier, where both interest rates and output increased. So that's how you would do it analytically. Any questions? But yeah, the way you would do any of these analytical questions is really just to like, based on, you have two constraints here, right? You have IS and LM and you want them to coincide. And so when you do the differentiation, you have two constraints, and then you are able to solve. Yeah, any questions about ISLM? Like, that doesn't have to be about the specific example that I went through. It's just because I think it's easier to go through an example, and then if the example raises any questions, then you can ask about it. Yes, Nikos.
Hi, do you mind re-explaining the differentiation, please?
Yeah, sure, I can do this. So basically what you're doing here is kind of like an implicit differentiation, right? So you don't care about C0 or C1T or G, because those are all exogenous things that didn't change. What you are specifically caring about is how a change in B0 will affect the endogenous variables Y and R. Because when B0 changes, Y and R are the things that are changing to accommodate that, not any of the other variables. Those are just fixed. And so how you do that is you're basically, how you would do the differentiation, it's basically, so suppose you have a function of y here. So let's say this is fy. Then, okay, fy equals to f prime y plus ir plus GB0. So how the differentiation works is that you take the derivative of this. Oh, I shouldn't use prime. Why would I do something like that? Notation is awful. Let's say HY. Okay, so I take the derivative of this, so F prime Y. But to indicate that that this is based on a shift, that this is how much like an if you had a marginal increase in Y, this is how much it would change by. That's the definition of a derivative, right? So if I increase Y by 1, how much will Fy change? It's F prime Y. So this is equal to, so this quantity is equal to F prime Y multiplied by how much I changed it by, dy. Does that make sense? And then this equals to H prime Y multiplied by how much I changed Y by. And then this equals to I prime R multiplied by how much I changed R by. And then this equals to G prime B0 multiplied by how much I changed B0 by. Is that sensible?
Yeah.
Just because like this is basically like a delta function, right? So if for each unit increase in Y, I get this much change in F prime Y, then I multiply that by how many unit increases I had in Y, and then I would get the exact value back. So that's like a very hand wavy way to say the algebra, but basically how you would do it is you would take the derivative and slap a dy next to it, and then you would take the other derivatives and slap the variables like thing next to it. And then when you have all of it in this nice form, since what you're caring about is B0 and like dB0 and dy, or dB0 and dr, then when you have two equations, that's enough for you to solve for these two. Does that make sense?
If we're looking at B0, why do we differentiate the minus B1R term?
Yeah, so that's because we care about the effects of increase in investment on output and interest rate. And the reason why we care about that is that ultimately interest rate and output are the stuff that is determined by every other exogenous variable. So you're given all of these other exogenous variables, C0, C1, T, B0, B1, G. And then your job is to figure out the optimal output and the equilibrium output and the equilibrium interest rate. So you can think of output and interest rate as basically free floating. And then they basically pick a value based on what all the other values are. And that's why in this case, you would still need to differentiate with respect to Y and R, because that's how the economy would like change its equilibrium, you know? Like in this case, if none of the variables were free floating, you would not be able to increase investment. Because suppose all of these are constants. I put Y equals to C0 plus C1, Y minus T, B plus B0 minus B1R plus G. Suppose all of them are constant. And then I try to increase B0. That's not possible, because in order to increase something, I need to decrease something else, right? So there must be some free floating variables that basically bring you back to equilibrium and make this an actual equality. And so the free floating variables are Y and R. Does that make sense? I can explain it again if you like in a different way.
No, I kind of understand what you're getting at. I think what's just tripping me up is the fact that we say like we're differentiating the ICE curve with respect to B0. but we're kind of like doing a lot more, you know what I mean? Like we're taking into account investment in general.
Yeah, so when you say you differentiate something with respect to B0, that means you're taking this, you're saying that B0 also changes. It's a given that at any period of time, Y and R can always change because those were never determined. But then when you say with respect to B0, you're saying that this variable that was once exogenous and that was once a given to us is now changing. And so we also want to model that effect. Because otherwise you wouldn't even include D of B0 inside. And you would only differentiate, like, then you would just say differentiating the IS curve, you would get, and then you would just get the Y and R terms.
Okay, thank you.
But good question. Any other questions? This can be kind of confusing, but like, honestly, at the end of the day, all you need to remember is like, differentiate it, put the D whatever based on what the variable you're differentiating with respect to is, and then, yeah, and then solve it. And then you should be good. Any other questions? Okay, I guess we can move on to open economy. So this is another analytical question. I didn't realize I put them both back to back. But yeah, so consider the following version of the open economy ISLM model. So over here, we're back to our traditional type of IS curve and traditional type of LM curve. And we the interest rate parity condition is given because he gave it in our final. I'm not sure if he'll give it in yours. So maybe you would do well to remember it, but yeah. So I said, derive analytically the effect of a change in nominal interest rate, which is E, on income, and explain this effect. So what you do is you go into the equations and you see which equations involve both E and Y, and that's the IS curve. And then you do the same thing, right? So which terms here depend on Y and which terms here depend on E. So over here, I see Y here, I see Y here, and I see E here. So then what I do is I differentiate Y with respect to Y. So 1 times dy, and then differentiate this term with respect to Y. So equals to C1 times dy. And then I differentiate this term with respect to E. So this is plus, and I put partial nx p star over p divide, like this is the partial derivative of like, it's basically the derivative of nx with respect to E. Like just like the way you would write that. And then you multiply it by dE. So if you think about it, this is exactly the same procedure that we had before. I cared about E and Y. So you throw everything else away and you just keep the terms with E and Y in it. So Y, Y, E. And then from there, and the reason why you don't involve interest rate in this situation, by the way, is because in open economy, you can also graph, like if you keep E as the free floating term, you can derive back R. So instead of having R as the free floating term like we had before, we have E instead. So you don't need to differentiate with respect to E, like with respect to R. So when I get this, then what I do is I solve, right? Because I want to know if I change the interest rate, sorry, the exchange rate, how would income be affected? So I get that 1 minus C1 dy equals to this derivative and then I finally get that my derivative of y equals to 1 minus C1 over partial x over p partial p. And then whenever you want to explain the effect, usually what you would care about is the sign. First of all, C1 is the relative like marginal propensity to consume. And this is definitely going to be always greater than 0, right? And then what you need to do is you need to analyze the sign of this bottom part, because that's the important one now. So how does net exports respond to an increase in exchange rate? Like, sorry, a depreciation of the exchange rate, where like E increases, which means your currency value is valued less. So when there's a depreciation of your country's economy, then what happens is that you are now, your domestic goods are cheaper than foreign goods. Sorry, I forgot the word for a second. So domestic goods are cheaper than foreign goods, which means you want to export more things, all right? So then your next net export should also be greater than 0. So if the numerator and the denominator are both greater than 0, then you have that this entire thing is greater than 0. And so yeah, this is the, well, yeah, this is the explanation. So as your nominal interest exchange rate increases, this is basically a nominal depreciation of your currency, which is, yeah, basically a real depreciation. So this depreciation makes domestic goods cheaper than foreign goods, which makes people from abroad want to purchase more foreign goods, and people in the economy people from abroad want to purchase goods from your economy, and people from within your economy don't want to purchase the more expensive versions from abroad. So that results in an increase in net exports. And so when net exports increase, since it is part of the IS curve, there is an increase in planned expenditure, which exceeds output, and then firms start to deplete their inventories, and then they increase employment and production. So there's an increase in output, which is the same explanation that it has been in the previous part. So it is useful to just remember, like, this part is like, you should just know how to write it, and you just like, as soon as you think about, okay, planned expenditure, and then you just start writing. Any questions about this? Sometimes exchange rates can be hard to figure in the head. Yes.
My question is just why we have to write it as a partial derivative for the like partial of nx e p over p, like all of that part. Why is it a partial, not just like a normal derivative?
Honestly, in my mind, all of them should be partial derivatives, but I don't think it's very complete. Okay, the biggest reason why it is a partial derivative is because net exports can depend on other things other than the nominal exchange rate. So you're just saying like, ignore all the other things that could change the net exports. We only care about the change in net exports as a direct result of change in nominal exchange rate.
Okay, yeah, that makes sense. That makes sense. Because like I guess all the other terms, it's implied that the whatever other coefficient is just a constant.
Yeah, exactly. And it's also saying like, because you're trying to decide on the effect of a change in exchange rate on income. So if you just took the regular derivative of net exports, it could have many other things, right? But you just want the effect of a change in exchange rate. That's why you specifically take the derivative with respect to the exchange rate. Does that sound good?
Yeah, sounds good. Thank you.
Okay, awesome. And yes, the next part is compare the effects of a decrease in government expenditure in an open economy with imperfect capital flows versus an open economy with perfect capital flow and flexible exchange rate. So here you should recall that capital flow, this capital flow, plus the net exports should equal to 0. And this is just the balance of payment statement, right? So this is the capital account, and this is the balance of trade account. This should always be balanced. So So in the case with imperfect capital mobility, it's kind of covered in notes, but basically how it goes is that our new IS curve is this. And what we're basically doing is you're saying that net exports equals to the minus of the capital flow, right? So over here, net exports, if you move capital flow to the other side, you get minus. And since in the IS curve, you have net exports, you just plunk it in, and then it just goes in here. So since and so as domestic interest rate increases, capital inflow increases because foreign investors want to take advantage of the increased interest rates in the domestic economy. And so there will be capital inflow, and capital inflow means that this is more negative. So the IS curve is still downward sloping in the YR space. And this analysis matters because if this was a function that increased in interest rates, then you cannot be sure anymore that the IS curve is downward sloping. Because the reason before that the IS curve was downward sloping is because as interest rates increase, investment decreases. But if there were two opposing forces, you can't say that for sure. So what you're basically saying is that, okay, so I know I've introduced this new term, but even with this new term, when interest rates increases, the plan expenditure will decrease. So it still remains downward sloping. And so now we have derived our new IS curve and we are able to plot it. Then we can finally compare the effects of the decrease in government expenditure. So we say that as government expenditure decreases, then the IS curve moves inwards. So at the original interest rate over here, this is the level of output, but then the level of planned expenditure is all the way over here. So since the output is greater than planned expenditure, the firms are accumulating excess and unplanned inventory. And so they start to decrease production and employment. And so the output decreases. Not only that, but as income decreases, so does the demand for money for transaction purposes. Same explanation as before. So for the money market to remain in equilibrium, then the interest rates need to decrease. So at this point, there are two forces. One is the previous aforementioned decrease in output. The second is that as there is a decrease in interest rates, then there's an increase in investment and decrease in capital flows. So if there's an increase in investment, there's an increase in planned expenditure. If there's a decrease in capital flows, since this sign is negative, there's yet again an increase in planned expenditure. So as output decreases and planned expenditure increases, then you kind of get back to this new equilibrium. Does that make sense? It's the same explanation as before, basically. A lot of it is kind of the same, but then you just add one little small thing. So that's the case with imperfect capital mobility, which is where we use the Y to R space. And the reason why we use the Y to R space is because capital mobility is with respect to interest rates. But then in the case with perfect capital mobility and flexible exchange rate, then we use the Y to E space. So you notice that the reason why you use the Y to E space and not the interest rates is because if there's perfect capital mobility and a flexible exchange rate, the domestic interest rate is forced to coincide with the world exchange rate because of interest rate parity. So there's only one level of output that is consistent with the equilibrium with equilibrium in the money market where you get interest rate parity, because you're basically with a flexible exchange rate, your domestic interest rate is not allowed to be different than the world exchange rate. If your domestic interest rate was greater than the world exchange, the world interest rate, sorry, then investors would come flooding in, and then they would try to take advantage of this increase, higher interest rate, which would depreciate your currency, and then your interest rate is no longer greater. Yeah. And so what we get is that the LM curve is a vertical line. And then we know that from above that like the IS curve is upward sloping in the YE line, like in the YE space, because as nominal exchange rate increases, in like output also increases. Sorry, I scrolled too far. So when there's a decrease in government expenditure, then there's a leftward shift in the IS curve. So there's a decrease in interest rates as in the same manner as before. And so like basically it's the same explanation as here. So as government expenditure decreases, then at the original interest rate, there's like the output is greater than planned expenditure, you accumulate unplanned inventories and output decreases. And then for the money market to remain in equilibrium, then the interest rate needs to decrease. So it's like the whole explanation, same thing. So all you know is that like there's a decrease in interest rates. But then in the open economy, you can't have that, because basically as soon as the interest rates are lower than the world's interest rates, people are going to start like running away from your economy, and they'll be starting to like have capital outflow in order to go to places with better exchange rates. So this causes the domestic currency to depreciate, and it keeps depreciating until there's an increase in net exports that directly offsets the initial decrease in government expenditure. So that's why you notice that this level of output remains unchanged. And the only thing that changes is the interest rate. Sorry, it's the exchange rate. Does that make sense? And crucially over here, the important thing is that there is no negative output shock from decreasing government expenditure in an open economy, whereas in a open economy with perfect capital flow, whereas with imperfect capital flow, there is a negative output shock. And so the result of this is basically saying that like the level of capital mobility really impacts the effectiveness of monetary and fiscal policy. So with like completely free capital mobility, fiscal policy no longer works because the government is unable to change the level of output. If it tried to change the level of output, there would basically be a response similar to like net exports will basically completely attenuate the entire response. So it's not useful. But at the same time, monetary policy is really useful in this situation because changes in interest rates will not only, like if you have a decrease in interest rates, not only will you increase investment, but you'll also induce a capital outflow, which will also increase net exports. So it's like doubly effective. So, and the contrast is that with imperfect capital mobility, fiscal policy is still kind of useful, but it's less effective than in a closed economy. And monetary policy is also useful, but to a smaller extent than a completely open economy, which is why we say that imperfect capital mobility is the middle ground between open economy and closed economy, like completely open, free flow and closed. Does that make sense? Yeah. Any questions about open economy?
Could you just repeat what you just said?
Yeah. So basically what I'm saying is that the imperfect capital mobility is the middle ground between an open and a closed economy. Because in an open economy, you cannot use fiscal policy, because if you increase government expenditure, it's just going to decrease net exports by the exact same amount. So at the end of the day, you're still back at the same output, which is the output that supports that interest rates that like matches with the world's interest rate. In a closed economy, like the monetary policy does not work to the extent that it does in a completely open economy, because in the completely open economy, let's say you want to do expansionary monetary policy. So how you do that is you would decrease interest rates, right? And then in a closed economy, you decrease interest rates and investment increases, and okay, you have a slight expansion. But in an open economy, not only does investment increase, but there's also an outflow of capital, which depreciates your currency and makes more foreign buyers buy your domestic products, which increases your net exports also. So it's not just investment that increases, it's also your net exports that increase. And so that's why it's way more useful to do monetary policy in an open economy. And so in the middle ground between the both of them is imperfect capital mobility, which is like fiscal policy is kind of useful, monetary policy is kind of useful, but it's not like the extremes that the completely open and completely closed economy are. Does that make sense?
Yeah, it makes better sense. So is that why in EY space, the LM is vertical line?
Yeah.
Okay.
The reason why the LM is the vertical line is because there is only one level of interest rate that matches with the world's interest rate. And the economy cannot move away from the world's interest rates because there will be foreign investors that basically move them back to the world's interest rate.
Mm-hmm. Yeah. Okay. That makes sense. All right. Thank you.
Okay. Any other questions? Okay, if not, I guess we can move on to medium run. So over here, so I said, assume that the economy, so this is the model, it's the same as the one you would have seen before. So I mentioned like, assume that economy was previously at equilibrium and it went through some natural disaster which destroyed some of their capital stock. So very specifically, it decreased the natural level of output, YN. So that's the part that it decreased. And all other factors stay the same. So using the ISLM PC diagram, show what happens to the economy in the new equilibrium. So when there's a natural rate, like when the natural level of output YN decreases, then you have that the PC curve shifts inwards. So in the short run, the economy is still fine and it's still at equilibrium. But then over here, you can see that there's this shift inwards in the PC curve, right? And so, yeah. And then over here, output is now above its new potential because this is the inflation rate. So this is the inflation rate, right? So as the PC curve moves inwards, then this is the new natural level of employment. But then right now, you're at this point. So you're clearly above the natural level of employment, which means that unemployment is also above the natural rate. And so the economy is not in a medium run equilibrium. So since there's a very low employment rate, because it's way above its natural rate, companies need to increase nominal wages so that workers will exert the appropriate amount of effort. And so this increase in nominal wages makes firms set a higher price because wages are production is more expensive. And then over here, inflation starts to exceed expectations. So we reach this level of inflation, which is greater than the expected level of inflation that we want. So yeah, and so this increase in prices and inflation reduces the supply of real money balances, M over P, because if P increases in M over P, then M over P decreases. And so this shifts the LM curve to the left. And so at this original output level, there is an immediate increase in interest rates until point A. And the reason why interest rate is the one that immediately increases is because the money market is always in equilibrium. So it immediately just jumps up here. So at this higher interest rate, the output definitely exceeds planned expenditure. And so firms start to accumulate their inventories, right? And so they decrease employment and production and they start moving back down. to this way. And so again, the explanation is that output decreases, and then not only that, but with an increase in interest rate, there is a decrease in planned expenditure, and then that closes the gap. And so now our new short run equilibrium is at R1n times Y1n, and we are at the level of employment, at the natural rate of employment, and at the correct inflation expectations. So you are in both short run and medium run equilibrium. Does that make sense? Yeah. So like basically how the explanation goes, usually it would be like a shock in IS or LM, but I wanted to do something different. So over here, it's specifically a shock in the PC. So you do start in a short run equilibrium and everything is fine in the short run. It's just that in the long run, since the PC curve has moved inwards, then you are no longer at equilibrium state and you're actually overproducing, which creates a higher level of inflation. And since there's a higher level of inflation, then the LM curve moves in because there's too much, there's too little real money. And then that changes the interest rates, and which decreases the production. Any questions about that? Yeah, but this is only going through one cycle. In theory, you could do as many cycles as possible as necessary. And there are some really disgusting questions like deflation. Yeah, deflation, where it's like you have to do so many cycles and it just cycles inwards and inwards and it gets really messy. So I would say that it's very useful for you to try to draw out the graphs in pencil first, and then like think about it in graphical format before you try to write stuff, because it gets pretty messy otherwise. Okay, if no questions about that, there's also a question about why would the natural unemployment rate be above 0? And so this is just about frictional and structural unemployment, which is, so frictional unemployment is when you're between jobs. Structural unemployment is when you don't have the right skills for the current jobs that are available. So that's why there would be a natural rate of unemployment that wouldn't be exactly 0. Yeah, and finally, or do you have any questions about medium run other than this also? Okay. And I guess finally we have monetary policy, last stretch. So in this specific scenario, it's the same ISL MP PC curve that we're given in the notes. And this is specifically about disinflation. So basically, when your base level of inflation is too high, like it kind of stays there, stays at that like high level of inflation until, as long as it's not a transitionary inflation, right? So if you have consistent inflation over a long period of time, it will stay there until the central bank conducts disinflation. And what that means is it's reducing its inflation target in order to bring the inflation back down. So the central bank decreases its inflation target from pi h to pi l. So over here, here was the old inflation target, here's the new inflation target. So when they decrease the target from the higher one to the lower one, then of course, by definition, it begins that inflation starts above target. So then the central bank increases the policy rate by this amount, where this is the beta is how hawkish or dovish the central bank is. And this is like the old inflation rate and the new target. So then the MP curve will shift up because of the increase in the policy rate. And so at this new policy rate, the output exceeds the planned expenditure. And so firms begin to accumulate unwanted inventories, and then they reduce production and employment, and then the economy enters a recession. So basically it's saying that at this R1, you're here, and you're at this Y1. And since this Y1 is less than the natural rate of output YN, you're in a recession. So in the short term, you're in a recession, but then since your output is below your actual potential YN, then your unemployment is greater than the natural rate. And so this results in decreases in nominal wage, which induces firms to set lower prices, and then the inflation falls to your new target. And so with the inflation at the lower target, then the central bank decides that they're going to shift the policy rate back because they've reached their target, right? So since they have reached their new inflation target, they're like, okay, I can bring it back to the natural level. And there's also, since the decrease in policy rate increases planned expenditure, then firms also begin to increase their inventory, like deplete their inventories, and then they increase production and employment, and they basically go back here. And so under adaptive expectations, then the Phillips curve shifts downwards. And at this natural level of unemployment, you have reached your new target inflation rate. Does that make sense? Yeah, so like basically usually how the explanation goes is that something changes, so there's a shock. Here the shock is that the central bank changes the inflation target. And so then they'll change the policy rate, which moves the MP curve. And then when you move the MP curve, then there's a change in output. And due to the change in output, then there is the economy is below or above its potential output. And so there is either too much or too little unemployment, which would then result in you needing to change the nominal wages. And then that any change in nominal wages would impact prices that firms set. So there's a change in inflation. And then since there's a change in inflation, then the central bank, seeing the different inflation, would move the MP curve again. And the Phillips curve will also shift because the public has adaptive expectations. So it expects the new level of inflation to be the same as the current level of inflation. Do you have any questions? I will say that I think that ISMP PC is the most confusing one. So if you have any questions about any of that, please feel free to ask. And I will do my best to try to elucidate. No questions? Okay. Yeah, and the last part is briefly explain what a deflationary spiral is and how it can occur. So basically, deflationary spiral is really just that when your natural rate of, like your natural policy rate, like interest rate that you want to set, is below the interest rate that you can set, then even though the central bank wants to set the policy rate below the natural level of interest, they can't. So then prices and production keeps declining. And that's the deflationary spiral. Yeah. Do you have any questions about that as well? But yeah, I mean, that's the end of the note. So if you have any questions about anything, actually, you could just feel free to unmute and ask. No, all good. All chilling. All ready to crush the exam.
Sorry, I have a question on one of the growth questions
Okay. Yes.
earlier, like in the notes. I was like skimming through.
Yes. What about it?
I think it's example 2.
Yes.
Part B, when it was like it's solved for 3 steady states. I was just wondering how we kind of got to there. It's like a little bit confusing because there's like K and K bar and all of that.
Okay. So the 3 steady states is basically the 3 points where, okay, let me draw it. So here is the actual investment curve, right? This is the actual investment curve. And this is the replacement investment curve. So the 3 steady states are where the 3 places where the actual investment equals to the replacement investment.
Oh, okay. Yeah, like graphically, I see it a bit better.
So-
Okay. And I guess we never solve like analytically for them, right? In the question.
No, I don't think I mean you. No, I mean I don't I mean you would in the traditional solo model, which looks like this, because you can just set this equals to this, and then you would have the solution because y equals to ki to the power of alpha.
Mhm.
And so then you will be able to solve for it. And that is the standard equation that you have where ki equals to s over alpha plus n like 1 to the 1 minus alpha. Something like that.
Mhm.
So this is the standard equation you get. And that is the steady state. And so you can solve for that. Over here, the reason why you cannot solve for that is because you have no, I don't think you have a proper, you don't have a proper definition of, I don't think you have a proper enough definition of what all the variables are. Maybe you could solve for them, who knows? But
Yeah, because I tried, like I made an attempt, and I don't think you really can. So that's what I was a bit confused on.
yeah, no, I think graphically it's quite clear that it's these 3 points. And
Mhm.
over here it says that it's enough to do it graphically, but you need to explain your result.
Okay, perfect. Thank you. That helps.
Yes. Andrew, differentiation of output and exchange rate. Yeah, of course. So here is, let me find the open economy. Okay. So over here, you want to find the effect of a change in E on Y. So you find your equation that has Y in it and E in it. And you don't care about these other things because they're irrelevant to how E affects Y. Because as far as you're concerned, all of these will remain constant when E changes. It's just Y that also changes along with E. So you take the partial derivative. So you take the derivative of this and you multiply by dy, derivative of this multiplied by dy, derivative of this multiplied by dE. And then you solve until you get dE over dy. Is there any specific part of it that you find more confusing that I could maybe help with?
So when, let me see. Is it possible to just isolate y to the left-hand side and then differentiate with respect to e, or like the other way around to get the same relationship?
I mean, if you move the sides of the equation, nothing really changes, other than the fact that you're doing this step first and then doing the differentiation. But like if you're doing valid algebraic maneuvers, you will always get back this. Because
Okay.
that's the definition of a derivative.
Okay, cool. Yeah, thank you then.
Okay. Any other questions? It doesn't have to be related to anything in here either. It can just be anything you like. Everyone's all good?
Quick question again. What was this the dr over db0 that's circled in?
ER over db0. Where is that?
Oh,
yeah,
this? the two, yeah, there's those two circled in.
Yeah, this is the, like, as B0 changes, what's the effect on interest rate? And as B0 changes, what's the effect on on output? Where B0 is the base rate of investment as we defined in the equation above over here.
Okay.
And so that's like basically exactly what the question is asking, is like, as base rate of investment increases, what happens to output and interest rate? And so this is literally like, as there is a 1 unit increase in base rate of investment, this is how interest rate responds. And as there is a 1 unit increase in base rate of investment, this is how output responds.
Do we have to put that it is bigger than 0? Like,
I mean, that's how you would show, you know, how it responds, I guess.
okay. I was like, I can get to up to like those like fraction part, but I'm
Because the
might
reason why
forget
it's
to
bigger
put
than
the
0 is because as defined above, and that's why you should read every part of the question very carefully. It's because, like, yeah. So it says that all these are positive. So this is positive, this is positive, this is positive, this is positive, and this is positive. So all of it's positive.
Okay. All right. Thank you.
Any other burning questions? If you're uncomfortable with being recorded, I can also stop the recording and we can keep talking. Everyone's good? Feeling ready for Friday?
If no one has question, could you explain again the open economy question B part again? Oh, I didn't quite understand that.
Okay. So over here, what's basically happening is that there's an open economy. There are two open economies. One of them has perfect capital flow. So, and the other one has imperfect capital flow. So when you do imperfect capital flow, how you model it is that capital flow is exactly equal to the net exports, right? Well, equal to the negative of the net exports.
Yeah.
And so when you put this into the IS curve, you get that it's still downward sloping.
Yeah.
That makes sense? Okay. So then if government expenditure decreases, then your IS curve is moving inwards. And then through all of the explanation, you get that this is the new equilibrium.
Oh.
Is the confusion the explanation here, or is it something else? Because this is the same explanation that has been in other things.
Okay. So in case this is in case of imperfect capital mobility.
Yes, imperfect capital flow.
And in perfect capital flow, it will be looking
at Y with respect to E. Because Y with respect to R no longer makes any sense because R will never change.
Okay. Yep, got it now.
So that's why E is the floating thing. And you know that E with respect to Y is increasing because we had just derived above that as E increases, as Y increases, E increases. So that's
Yes. Okay, got it.
And so yeah, then you stay at the same level of output because your LM curve can't move without their without, because there's like because the interest rate is fixed and there's only one level of output that supports that fixed interest rate.
Yeah, that makes sense. Yeah. Okay.
And like interest rate is fixed is like a very colloquial way of saying it. The interest rate isn't fixed. But what's basically happening is that whenever there is a change in interest, whenever there is a change in interest rates, there's going to be capital inflow that just like swoops in.
Mm-hmm.
And then it depreciates your currency. And then there's a similar change in net exports.
Okay. So if Canadian dollar gives higher interest rate than USD,
then US investors will want to put their money in Canada. Which means that so this results in a capital inflow, but then that since this bids up the prices of Canadian dollars because more people want to buy Canadian dollars. So the Canadian dollar appreciates. And so since the Canadian dollar is more expensive with respect to the US dollar, then US consumers don't want to buy Canadian goods as much anymore. And Canadian consumers don't want to import US goods so much anymore because it gets more expensive. So by right, this change in a perfectly open economy, this change exactly offsets any benefit you have from changing interest rates.
Okay, so that's why exchange rate depends directly on like output. Okay.
Yeah, and then the output doesn't change at all. You know, it just gets exactly offset.
Okay. Okay, that makes sense. Yeah. Is there any ways the LM can like move left to right?
Yeah.
The vertical line.
Yeah. The LM could probably move because of changes in I would say change in interest rate would cause, would it? Let me think. Change in interest rate. Yeah, I think so. I mean, I can check directly. Let's see. Huh. Okay, so changes. I'm pretty sure the LM can move. Let me figure out when the LM moves. Yeah, I guess like expansionary monetary policy.
Okay. So in that case, R goes down, so Canadian currency relative to US currency devalues.
So at the so at the same level of exchange rate, there's a different amount of output. Just because, yeah, I think.
So could we go back to using the Canadian and US dollar example? Let's say Canadian does expansionary policy.
Yes.
That would lower exchange rate, right?
So if interest rates decrease, then exchange rate, so Canadian dollars will depreciate. And so there will be, so actually let me just draw it. Yes, I think I can just draw it. So
so if there's more money supply, Canadian dollar depreciates, so there's increase in exchange rate, right?
Well, there's a depreciation of the currency basically.
Okay.
So
because I saw that in one of the questions, and
here's the LM0 and here's LM1.
Yeah, this is the expansionary policy.
Right. So over here's the initial exchange rate. But then because of a change in interest rates, that induces the exchange rate to induces the nominal exchange rate to go up.
Okay.
Because when your interest rate is lower than the lower than the world level, then the US investors will leave Canada because it's not worth it to stay in here anymore.
Yeah.
So they try to sell the Canadian currency, there's too much supply of Canadian currency, which causes Canadian currency to depreciate. And then when Canadian currency depreciates, then it pushes the exchange rate upwards. And then and the reason why it's a movement along the IS curve is because this increase in output is all because of the increase in exchange rates. So there's an increase in nominal exchange rates, and that creates an increase in net exports.
Okay.
And that pushes output from Y0 to Y1.
So since no one wants Canadian dollar, interest rate would go up eventually, right? For Canadian dollar?
No. I mean,
No?
like how it balances off is that people
Yeah.
Canadian dollars, like use Canadian dollars to buy Canadian goods. So to balance the capital outflow, you have balance of trade going in. That's how the balance of payments works.
Ah, right. So it's cheaper to buy Canadian goods, you mean?
Yes, exactly.
Okay, and that brings back the exchange rate.
Yeah.
Okay, so it comes back to Y0 eventually?
No, it doesn't go back to Y0. Because the interest rates are kept at this specific state, right? And so basically how it works is that based on the interest rates, it must have parity, which means that R must equal to, like, the exchange rate in your country, R must equal to E times the exchange rate abroad, or something like that. Or maybe it should be 1 plus R equals to E times 1 plus R star.
Okay.
And so since the government decreased the exchange rate over here. So over here, if you decrease the exchange rate and then if you decrease the interest rate and the exchange rate increased, then you can remain at equilibrium.
Okay, that makes sense. And I was just
on the wrong
asking, like,
side. It should be E times 1 plus. This is local, this is abroad. So if you increase this and this decreases by the same amount, then you can still match the interest rate abroad.
Okay.
So as you decrease the interest rates, like here to here, you decrease interest rates, but then the exchange rate increased. Then you're still matching the world's exchange rate.
Okay. Got it.
Sorry, that was a very convoluted explanation. I was also trying to figure it out myself.
No, I got it. Thanks so much.
Any other questions? Damn, everyone's just chilling. All good? Everyone good?
For the most part, I think I'm good, at least after reading your notes. Fingers crossed.
Yeah, no, I mean, honestly, don't stress. I feel like the biggest exam advice I would give for this class is, and I think you would already know from having taken his previous exams or seen the previous exams, but his exams are really bloody long for the amount of time you're given.
Uh-huh.
So if you have any doubt or if you're hesitating too long on one question, just skip it and go back to it later. Because otherwise you will not
Got it.
like guaranteed. Like if you think you're running ahead of time, that's good, because you're gonna run into like a roadblock further down. If you burn too much time early on, then you don't have time for all the roadblocks early on, like later on. And usually how he does his grades distribution is like the first few questions are worth quite low percent, and then the last few questions are like the whoppers with like 30-40%, that kind of stuff. So always run ahead of time. If you feel like there's no rush, still rush. If you end up with more time, you can just check or like go over the stuff that you didn't really feel like you did very well. But I think, yeah, at the end of the day, like, do have a sense of urgency as you do the exam, because like sometimes it does get quite sneaky, and like some of the further questions also need more thinking, because the first few questions are usually like explanation questions or derivation questions, and the last few questions is like, so this model that you now know back to front, yeah, we're going to change this one small thing, so now everything is flipped, so how do you solve that? And then that requires more thinking. The more time you have, the more calm you'll be when you're thinking things through, and the easier you'll get it. As soon as you start panicking, then even if you could have solved it when you were super calm, it gets really, really hard. So, you know, rest well, take a chill pill. His notes are really good. You should read them. You should look at our past finals. And yeah, overall, it'll be good. It'll be good. And he grades rather nicely. I don't think he grades as nicely for the final as he does for the midterms, but he still grades rather nicely. Yar, any final thoughts, last words?
Does ESA have like practice final?
I mean, I have my final.
Is it in the GitHub? Did I miss it?
It's I think he gave you all my final.
Oh, okay.
But the thing is that he has never, like, that was his first time teaching both D1 and D2, as I said. So,
oh, really?
Yeah, he before it was split between him and someone else. So he would teach someone else to teach D2, which is why you don't really have a lot of examples of like consolidated finals, because last year, the year he gave us a final, was the first final that he ever made.
Oh, okay, that makes sense.
Which was very annoying to have to study for without many inclinations. But I mean, he does give you the additional exercises, I guess.
Yeah. Okay.
And look through additional exercises, assignments. But I would say all in all, don't try to pattern match too much, like really understand what you're doing, because if he changes the model just a little bit, then a lot of things change. And like, yeah, his questions are all just like, this is the model, we change this thing, so what happens then? So I would maybe prioritize, like, I would practice so that you get the exam, like the explanations till second nature. So you can immediately say, plan expenditure, firms accumulate inventories, blah, 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 output decreases, that kind of thing. That should be natural. But then once you've gotten that down, and once you know all the movements down, I would say maybe spend some time looking at the notes, because he also sometimes has like questions about like, oh, you know, calculate inflation rate, blah, blah.
Okay, that makes sense. So does he usually gives out the MP and PC those equations, or?
I wouldn't know, because that again, there was his only final and his only second midterm. But I would say that like, be prepared for every single topic, especially towards the latter half of the course.
Yeah, fair enough.
Like,
is it D2 heavy or D1 heavy, or is it about the same?
I mean, I can check the exact percentages for my final. It was 15 plus 5, 20. It was D2 heavy for us, but it was like a 40-60 split. So it's not that heavy. It's like,
okay, that makes sense. Sounds good. All right. Thank you so much.
Thank you for asking all the questions.
Thank you for your time.
Let me just stop the recording.